Hello and welcome back. My name is Corey and you're my rubber ducks, and this is the series of episodes where we are creating a new programming language from scratch. That is, we're using a terminal window, Vim as our editor, C++, modernish C++, and tools like Flex and Bison, and we are designing a brand new programming language. The language is called Tang. It is stands for Template Language. That is, this is designed to be a templating language for generating, for example, HTML. Yeah, actually, that's a good way of putting it. I was going to say for generating HTML templates. No. This is to interpret a template that will generate HTML. So what we have been focusing on lately is getting Unicode working with ICU. That's working. And now we're going to start in our, the episode we just did is we got negative indexes working in arrays and in strings. And we got indexes working in strings with multi code point characters. That took a little bit of doing. But, all right, so where does that put us today? We are on part 2. What episode number is this? Episode number 48. And that is, we are working on, I call it collections because a string is a collection of graphemes from our perspective, and an array is a collection of entries. And those are the two that we're focusing on, but that's what we're wanting to do, wanting to support. Well, the newest thing that we want to work on is slicing. And what is slicing? Well, we're taking this, taking the inspiration from Python on this. And I think on the right-hand side, I'll just Python 3. There we go. And if I have an array A that's equal to, 0, 1, 2, 3, and then how about A, B, and C? Sure, that works. And if I want, a specific element, I could say A sub 3. Well, that's the third one. But of course, if I say A minus 1, again, we already implemented this. That's the last element, C. But I can get a part of the array. So I could say A sub, A sub 2 is 2. But if I say A sub 2 colon, that is what's called a slice. And that would be the idea of to the end. Or if I had said A sub 2 colon 4, well, let's do 5. That would be elements 2, 3, and 4. So it's up to but not including the last one, the last index number. And then we can say, well, we can even do, let's say -4 to -1. And that's going to give me the 3AB. 3AB. Why? Because up to but not including the -1, which is C. The -1th position. Negative counts from the end, remember? And then we can do other things like I could say, give me, from the beginning, actually, well, yeah, I'll go ahead and say it this way. So from 5 to 2 and do -1. Well, that means it's going to go backwards. So here we see BA3. So 5, if we go up to the original 0, 1, 2, 3, 4, 5, B is the 5th one. And I say go down to 2. What is the 2? 0, 1, 2. So up to but not including the 2. So it gave me BA3. We can do other things. So if we say 5 colon and leave a blank there and do -1, then that will be from 5 back to the beginning. What if I do 5 negative? How many things are in there? 1, 2, -7. So if I do -7, it's, oh, I wanted the end. Let's do -1, -7, -1. So CBA 1, 2, 3. What if I take this up to -8? That will include the 0, the first one, and what if I do -9? It does, it maxes out at -8. Okay, that's fine. And yeah, so we can see this behavior. We get some interesting things. If I say A:::, it's the exact same array. If I say A:::-1, I get the array, but all the elements reversed. And if I have, let's say, B is equal to, hello world, and I do B:::, -1, it inverts the string. And of course, all the same things apply. I can say from the -2 to the 2. Why not? And that it basically I got that part of the string in reverse. So yeah, this is the idea of slicing that we want to support. Now, it's worth mentioning here we go. And we have this Unicode converter website. And we copied in the flag of Scotland. And remember, this is a bunch of Unicode points. It's even more characters. We can use... I think we can use this one in Python. If I were to say, for example, that B is equal to this. Okay, so B is equal to those characters. And I want to reverse it. What does it give me? You say, Corey, we can't see that. Okay, there. Scroll up. If we look, UD83C is at the beginning of B. Really? Okay, UD83C is at the beginning of B, as we can see here, but when I said print it out reverse, it's at the end. And UDFF4 is the next to the end. And if we go all the way to the end, what's the last one? UDC7F, that's the first one. And that's not right. Well, it's correct in the terms of the code points, the code points, yes, have been reversed, but these code points, when in this order, form a grapheme. And so this is now broken. And if I said, only give me the last, so if I said B 1, there, it gave me DFF4, which is the sub 1, right? In other words, it's not thinking of them as a grapheme, as a unit. And that is not good. That is, if you're dealing with Unicode characters, you say, well, Corey, there's other libraries you can do, other ways of writing it. Yeah, but I'm talking about the default behavior of strings in Python does not account for this. And we want ours to account for it. That's the point of using ICU. And it should just work without the user having to do anything special. So that's the goal. So where do we need to go? Well, first, we're going to, let's exit out of this and As usual, I say this is 100% live coding. You're going to see all of my mistakes in all of their glory and the debugging procedure that can be long sometimes. And we will say, so git log, the very last thing that I committed was the end of episode 47. And if I say git status, you'll see that there's no changes have been done. And we have a working build on the right-hand side. As well, we'll see that as soon as it finishes compiling. So where we're going to go, the first thing I want to do is I don't think we're printing out arrays, and we need to. So let's, in order to do the slicing, in order to test the slicing, we need to be able to print out an array. So we'll just start off with editing the tests. And do I have something for print? Printing default. That is it. So we're going to create a new thing here. And we will say print array. There we go. Zero, 1, 2. And what do I think that this should look like? Let's make sure that I don't even need that one. We're going to execute it and get the output as 0, 1, 2. That's what we want. And if we have 0, A, 2, then it should print out 0, and then double quotes, A, double quote, 2. That's what we want. So, of numbers, separated values and no spaces after the comma. All right. Print out an array that contains a string I'm thinking. Where the string is enclosed in double quotes. And then lastly, or firstly, depending on how you look at it. Whoops. Sorry, just looking at something. Yeah, that's what I thought. It copied 55 lines instead of 5, and then I pasted that, so I was just undoing that. Okay. An array of numbers, and in this case, print out an empty array. Nope, that was wrong. Okay, so none of these are working. That's fine. We're about to make them work. In order to do this, we need to do the include for a computed expression array. Edit the source for computed expression array. And let's edit the include for just computed expression. So when I say dump, is that what I'm using for print? Let's edit the source program execute. When I see print, I'm using dump. Why is that bad? Well, dump is, it outputs the value. The problem is if it's a string, it's not going to put the double quotes, and I don't want the array to have some sort of special handling. We could use the Python approach where they have a repr, R-E-P-R, representation is what it stands for, as well as a string, a dunder str and a dunder repr. Maybe that's what we need to do. Do we have anything else that we're using? So we've got our is equals, our garbage collected stuff. This is all garbage collected, garbage collected. We don't have anything else. We're going to have to for the done, sorry. Okay, so now we're going to, let's just create a dunder. What do I want to call this? Representation? The point is, I don't like to how about as code? I think I like that better, and we'll output the contents as a string as it may similar to how it would be represented as code. How about that? And it will return a string representation. Okay, so we've got this as code. Now we need to add a edit the source for computed expression, and as code is what we need. Okay, so computed expression, where's dump? Oh, there it is, right there. And we may get rid of dump in the future. But I do like as code, I think. Did we use all caps for null? I don't remember. There's an easy way to find out. Flex. No, we use lowercase. So, segmentation fault, probably because we need to recompile everything. That's fine, we'll get there. Now, for the computed expression array, when we're printing it, we need to call the, or use the as code dump. Yes, I think that's what we'll do. So let's edit the computed expression array. We've got our dump, and we're going to have an as code. Okay. And here, oh, I did have a dump of some sort. But it should be as code, and the dump should just return oh, should be under as code, yeah. So, first of all, why are we getting segmentation faults? Because something needs to be rebuilt. There we go. Now, for each of these, we want to, instead of doing item dump, we want it to be an as code as well. Yes. So normally, let's give ourselves a little bit of help. Let's do this in our computed expression. Nope, not that one. In our computed expression, so that's a buffer 6 now. What does the, let's say our as code is going to fall back on return this dump. Okay? And now this needs to be don't know why it did that. Null. It's probably going to break some tests. Suppose it didn't. And now our arrays are still not printing anything. Shouldn't they be? I would think so. Just because the as code actually, I can just get rid of this now. This is all right, so now, why did I do all of that? Well, because now the dump is going to call the as code for everything. And I can say for everything else, an integer, a number that is a floating point, a Boolean will be true, false. Those should all just work. But a string, I can give a different behavior for as code versus dump. Dump won't include the parentheses, but as code will. However, the problem is well, this isn't working. If I look at my tests on line 1029, that's this one right here, I should have an empty one, and I'm not. So the question is why is it not printing? In fact, none of them are printing. So why are my arrays not printing? So computed expression array, I have a dump. Dump, blah, blah, blah. Here. And it never prints out here. So now I'm wondering if it's given as a virtual override, so I didn't forget that. Let's go back to the before I go too much further, I want to double check something. What if I just do cout p1 dot, is it dump or get? Dump bytecode. I just want to see what this outputs. Array 0, print. Seems like that is correct. How about p1 dot get result? Oh, it's not liking that. Oh. Have to dereference it. There we go. Don't know how to cast this value to a string. Interesting. So it, oh. That's why. That's what's missing. Okay. Okay. So, computed expression array. Well, computed expression.hpp. Actually, let's look at the execute for the print. And what does it do? It calls dunder string. Oh, I was reading that and I didn't read any of the code around it. That's only if it's computed expression error. So, all right, that's fine. But I need a dunder string. So maybe dump doesn't need to exist in the grand scheme of things. We'll deal with that at another time. But what does this look like? Where's the dunder string? There we go. Oh, and this should be override. Garbage collected. Make computed expression string. Not wrapper as code. I'll do that. Didn't need the word virtual there either. There we go. Now, okay, so everything is passing except for one thing, and that is where we put a string in here, because the string is just defaulting to dump, which is just, yeah. So I need to edit the include for computed expression string and edit the source for computed expression string. And now I've got my dump, and I'm going to add a as code. And where's my dump? As code, and I'm going to do, I may have to say string plus that plus that should work. Oh, didn't like that. Because I need a plus sign. Okay, so now it's really not working. Oh, it's a Unicode string. I don't think it's going to like that, because it's not going to know what to do for the all of that's a Unicode string and a const char. So I don't have a constructor for a plus between the two. The fast way to fix it is to just say Unicode string. Okay. Everything's passing. That took a little doing, but okay. Just looking through the changes, and I will say we added as code methods so that arrays are printed nicely. And their contained values are printed nicely. Sure. Now we can get on to slicing. How about that? This is probably going to be part 2 of part 3. In order to do slicing, we already talked about what slicing is. We need something to hold the slices. And so that's going to be an AST node. So I'm going to go into the make file, and we've got this. So we've got all these AST nodes, and we need we'll just put it right here. Instead of return AST node slice. Okay. And then it goes after return. (122, 123), and what are we doing? We're substituting return for slice. All right, now it's going to say, hey, I don't know how to make that. That's fine. We're about to supply this need. And we are going to copy our includes AST node. Which one do we want to copy? I think it's going to have 3 parts. We could do the ternary. Oh, I need to, where am I copying this to? Include AST node slice.hpp. And we'll do the same thing. Source AST node ternary to source AST node slice.cpp. And so slicing is going to change our opcodes because we're going to need a slice opcode. And do we need a computed expression for a slice? No. We can push on the parts onto the stack and then call op slice, and it can pop it off. That's what we're going to do. So we're going to edit our, let's do the opcode first. Source, no, include opcodes. And where's this going to be? I think I want it after index. Slice. So we're going to pop, skip, pop, end, pop, begin, pop, collection, push, collection, begin, end, skip. That's what a slice is. And I'm just going to Control C, Y, just make clean, test-watch, okay. Now we're going to edit our our source program dump, and slice goes after index. So there we go. That's the dump bytecode. And now we're going to edit the source program execute. opcode look for index. There we go. And instead of index, it's going to be slice. And what do? We need to do a stack check for 4 things. And it's going to be, so container is last, but it's going to be skip is the first thing that's popped off, end, and then begin. I think I use different words in the other, but that's fine. And now we push back container dunder slice that we're about to add. Begin, end, skip. And that's going to do all the work. And it's saying, hey, I don't know what dunder slice is. That's because we have to write it. So now if we do our include for a computed expression, and there we go. Perform a slice operation. And we will say this is going to be the start. So this is going to be the start index expression, end, and this will be the skip. And I'm just going to add follow Python semantics in which a skip, no, in which a slice, that's what this is, will start at the provided index position and go up to, but not including, the end index. The slice will default to an index increment of 1, but can be defined integer value. All right, and now this is not index, this is start, and then end, and then skip, start, end, and skip. All right. Now edit the source for computed expression and just copy this one. And instead of it being called index, it will be called slice. Start, or is it begin? I think it's supposed to be begin, end, and skip. How to slice this expression. Begin, and this will be begin, end, and skip. All right, so let's see where this is now. We haven't told Flex or Bison how to understand a skip, but we'll get there. And slice. Okay, no declaration matches garbage collected, garbage collected, garbage collected, const. Under slice. Begin. Maybe unused end. Maybe unused skip. Const. So what have I... What am I messing up here? Oh. Do you see it? I didn't change the name. Right here, this should be slice. I was going to be complaining that we haven't actually written the AST node slice. Yeah, that's what that is. Because ternary has multiple definitions. So, I don't think we've got that yet. No, we don't. So we're going to open this up. We're going to edit the include for AST node slice. We'll just get there. And what do we need to do? First of all, we need to undo that. Colon %s, and what do we need to replace ternary with what did I say this is? This is slice. And we will do the same thing for the title case. Ternary with slice. All right. And now our constructor is begin of the slice. end, and then this is going to be the skip. The skip index of the slice. And then its location. Yeah, we gotta have that. So this is going to be begin and slice. That's fine. We'll do something for the dump. We'll do something for the compile. And do we need a compile? Yes, we do. There we go, and the skip. Okay, begin and then skip, so that should be fine. And now we need to edit the source for AST node slice, and we've got a, there we go. So AST node slice, and we're going to %s change, oh, so that should be colon %s, and globally we're going to change condition to be begin. Globally, we're going to change true expression to be end. And globally, we're going to change false expression to be skip. All right, so now let's see. So we've got our AST node slice, begin, end, skip, location, passing location, begin, and skip. That's good. A slice, this needs to be begin. End. Slice. Slice. Skip. Begin and skip. What does a compile for this look like? All that we need to do is we need to begin. So we push on the begin. End and skip. Oh. Here, let's just, there we go. And now add an opcode for oh, I forgot the collection. Yeah, that's supposed to be in there. We'll add it, don't worry. There should be slice, so there should be a fourth thing there. Don't need that one. Don't need that. Don't need that. collection, compile, program. So what is collection? We haven't done it yet. Because I forgot it. So we're going to add here, the first thing should be collection. And now we need to add it right here as well. Collection. Okay, and now add collection to which will be sliced. And now just need to add that to our okay, so that was a lot of changes just really quickly, but getting our AST node in place. I think everything's going to compile, but I haven't written anything with the slice yet. So let's write a test, shall we? And where are our index stuff? String index. I think I want to do the, because where does this put us time-wise? We're at about an hour in, and that's actually pretty good. We don't want to assign indexes yet. This is... assign index. What's after assign index? Control flow. Let's put it here. We can do that. And we can do, this is going to be an array slice. The goal is to be this of a default should just be one, two, 3. That's the thought. Yeah, and let's just create. So this is going to be slice with all default values. And then a slice with all with default begin and end, but -1 skip. And then this should be 3, 2, 1. Okay. These should fail because we haven't told Flex or Bison how to recognize a skip. So let's do that. We're going to edit. Let's do Flex first. And are we already... colon. That's what I want to know. Oh, yeah, we're already recognized a colon, so we don't have to do anything in Flex. That's nice. Just exit that. And now let's edit Bison. And this is going to go... Now, here's the problem. The fact that we can have a null value. So, do we have optional? A for expression is an optional expression. Where is it used? So, I don't like calling it for expression because I'm going to change this. So, for expression. So here's what we're going to do. I'm going to %s, oops, yeah, for expression, and we're going to change this to optional expression because it's used in a lot of places. So there we go. Optional expression is an expression that, if not present, will default to a null value. Okay. That's fine. Why? Because now we want to decide what a slice is. So in order to do that, we're going up to our types, and we're going to have a type that is a slice. Okay. And now what would this look like? So slice is going to be represented by an AST node. So happens it'll be the AST node slice that we just added, which means we need to add that to our pound includes, which is right here. AST node slice. And just give me a warning that slice is defined, but it's never used. Okay, fine. We'll do that. Or that is, we're about to add it. So where are we going to put this? Statement, open statement, expression. Expression list. Where's the optional? Optional. Let's do it right here. A slice operation on a container. Yeah, that's fine. Okay. Oops. So slice. It will be an expression followed by that, followed by an optional expression, followed by a colon, followed by another optional expression, followed by another colon, followed by another optional expression, followed by a closing one. And if I see that, then that means I need to do something. We're going to say is equal to make shared AST node slice, and I need to give it these 4 things: the $1, $3, $5, $7, 1, 2, 3, 4, 5, 6, 7, and then at, we'll say 1. Now, it is possible to have it with only a single colon, and in that case, we need, instead of the 7, it can be that right there. So we can have a slice that is with 2 colons or 1 colon, but nothing else. And then now we need to say, well, what is this? And where can a slice occur? And the answer is, it's an expression. So slice, and it will default to just passing whatever slice recognizes. And now we're probably, as soon as I save this, I think it's going to tell me that it has some shift. It did not. Oh, because I've already, why did I think it might? Because shift reduce conflict because of the square brackets, but we already set the precedence for those. So, yeah. Notice we're not getting any errors, but our code still doesn't know what to do. That is, at this point, we should, by the way, if I were to go back to our test, where's test? If I'm in the test right here and I say, for this one right here, if I were to say, cout p1 dot dump bytecode. So we have an int val, null val that's reserving the spot for the variable a, integer 1, 2, 3, array 3 that creates the array, null val, null val, null val, that is our, for the slice that we're creating. Yep. So that's creating an array on the stack, creating a slice, put that in position A. Now pop it, pop it because we're done with the statement, peek it back and print it. It should work if we knew what to do with the slice. That's what we're going to add next. So believe it or not, we're so close at the moment. That's a good thing. So, and actually, if I do this here, I just want to make sure that my -1 comes through. Yeah, 0, 0, 1, negative. Slice, poke, yeah. Okay, that's good. It's working as intended. And now for our I'm going to exit this because I just want to start from scratch. The test will be open. The include for computed expression array. The source for computed expression array. And the yeah, I'll do the include for a regular computed expression and the source for a computed expression. Why? Just so that we have them. So if I go to 3, this is computed expression array. There we go. Computed expression.hpp, and we're looking for slice. And that is right here. I just want to grab its definition and go here, so it should be right after this, and we need to add an override at the end, which we did. Now we need to where's slice? There we go. Buffer 3. And our index is right here. So now slice is going to be right here. Oh, I need to computed expression array. Still is going to be failing, but everything should be compiling without error. And running without seg faults. That's always good. Now, we can start saying, well, what are our values in this? And I'm going to do this. First of all, I'm just going to remove the may be unused here. Because we're using all of them. And let's just start from the beginning. Verify that the skip is either default or an integer. All right, so the skip is, we can start there. So if the type ID of skip is equal to the type ID of computed expression, then it's going to be a default. So we're going to have an int begin, end, and skip, and Boolean values for nope, we'll just deal with this. Begin and skip. Okay. Skip is default. Default value, and so we'll say skip is equal to 1. Else, if type ID of star skip is equal to the type ID of a computed expression integer, that's another good thing. Skip is equal to a static cast computed expression integer ampersand. No, I don't need that. Of skip dot val. That should work. Else, just gonna put that there and just say, can you, oh yeah, it doesn't. Yeah, I shouldn't be shadowing, should I? No, I should not. Shadowing, because these are the name of the args, and I'm trying to use them for variables. Conv begin, conv end, conv skip. So converted. Begin, end, and skip. Okay, and all that I'm looking for is, did it... Unused, unused, set but not used, unused, unused. I can live with that. I just want to make sure that we're, before I copy and paste stuff. Okay, so we've got this. Verify that skip is either default or an integer. That's fine. Now, verify that the begin, so begin is a default value, is equal to 0. Well, the question is skip greater than 0? And if it is, that means it's positive, and that means the begin should start at 0. Otherwise, it should be this arrow, an array. What is it? Contents? Arrow contents. This arrow contents I was going to say dot size, but I'm thinking it should be the last one. So it should be size minus 1. So it will begin from, yeah, the last thing, if skip is minus 0. Now, if skip is double equal to 0, if not skip, then that's just so that we can't have a, yeah, skip a 0. Okay. Begin is that, then all right, so verify that the begin is either default or an integer. So if it's default, then we say, well, what is skip? Is skip positive? Then we're going to start at 0. If it's negative, then we're going to start at the end. All right. Now, if it's an integer, then we'll make sure that it's within the range. Or not within the range. That'll be a later test. Begin is an integer. There we go. Now, kind of the same thing, but with end. Verify that the end can I do this? 98 comma 100, and we're going to substitute begin for end, and we'll do the same thing for capital begin and capital end. Oh, because I said 100, it should have been 110. All right. And now let's figure out what I broke. So for the end, if skip is greater than 0, the end should be the size, but not size minus 1. Because it's up to but not including. All right, and then if it's less than 1, then the end should be up to but not including -1. Yeah, because we're going to be going down. However, this is a problem. No, we can fix this. It is an integer. That's fine. First of all, let's fix whatever compile errors we've got. Oh, that should be skip convert. Or conv skip. Line 88, I don't know how to write a ternary expression, it seems like. Unused but set, unused but set. We're good. Well, almost good. So now the question is what if begin is an integer and it's a negative value? Well, at this point, we want to convert that into the positive value that it should be. So, we will... Do I do this? So, for the... it should not be returned, but what I'm doing is I'm saying conv begin is equal to conv begin is greater than or equal to 0. So if it's positive, then we're not going to change a thing. If it's less than, then we will say that I know that what this was doing is it was saying if you're specifically asking for, this came from the index, I stole it from the index, but if it's less than 0, then we're saying, I mean, in the index it was out of range, but in this case, for a slice, they can be out of range, it's just it'll be an empty array if something's out of range. Okay, so if the begin is less than 0, then it is the size. Oh. the contents size plus the begin, conv begin, and is that correct? This is for the begin. This needs to be the max of 0 and conv begin, and the min of those. It shouldn't be any bigger than this contents dot size. Am I overthinking it? So this is where we're starting. Can we start? I don't think I need to include the min. In this particular one, I do want the max of 0 and the size, so it will always start at a safe place. I think that's fine. All right. Let's do the same thing for the end. Conv end is equal to conv end is greater than or equal to 0. If it's positive, then we'll just say conv end. If it's negative, you know what? I don't think we need to worry about this min or max thing yet. And maybe we'll need to. Contents.size plus conv end. All right. So that should be our skip, our begin, and our end. Still not working yet, but it should compile. Okay. Now, we just need to do two things. If conv skip, so this converted skip is greater than 0, then we do one thing. Else skip is negative, and we do something else. So skip is positive. So we're going to say for size t, start is equal to, and here's where it is, the larger the two, the max of 0 or where conv start is. Not start, Might as well just use I. We can say I is less than contents.size and I is less than conv end plus, no, I plus equals skip. What do? We need to have a new, a computed expression. That's the point. And we will say vector of garbage collected, and this is going to be new container. This is going to be assemble the target container. All right, so skip is positive. So we're going to, wherever conv start is, if for some reason it was negative because they said that it's only, the container only has 3 things, but they said start at -8, you have to put it way back. And we're saying take the max of 0 and start, conv start, so it's going to be either 0 or what conv start actually is. While it's less than size and it's less than the end, we're going to do something, and all that we're going to do is we're going to say new container push back, and it's going to be so we're on line 123. Give me just a second. I'm looking down. Not as code. Not assign index. Come on, where are you? I know what I'm looking for. Item is copy needed. All right. There we go. And of course, it's not item. It's going to be this. I could just say auto ampersand item is equal to this contents dot at I. Item is copy needed. Item make copy, else item itself. Why? Because this should be a const. procedure. It is. Okay. So I cannot use the square bracket because that would insert. Would it? I think it would. That's fine. So what are we doing? We're saying, do I need to make a copy of this? Some things, it doesn't matter, right? If it's a number, I don't need to make a copy. If it's a vector, I probably do. So is the copy needed? Yes or no? Then there's the end of that. Return garbage collected, make computed expression array, and we're going to feed it the new container. And I think rather than new container, because it's contents, I would rather have contents, new contents. What's funny is that should Gargabe. BAGE. And conv start, conv begin. Oh, size T. Wait, what? Where do I have a size T? That's right. Conv end. These are all integers. Okay. So rather than calling this a size T, I think it would be better if it's an int. We'll just say, cast that to an int size. No match for plus equals for, oh, the skip. It should be conv skip. The converted skip. One of our tests is passing. The one with the positive, well, it wasn't necessarily a positive skip. Well, it was, but it was a default skip, which should that work? Okay. Words hard, difficult, much bad at Corey is. So if the skip is negative, then we're just gonna yank these 4 lines, and so where are we going to go? We're going to say I is the min of this contents dot size minus 1, right? So we're going to start at the end or conv begin. Then we're going to say while it is greater than or equal to 0 and it is greater than conv end plus equals a skip. Why plus equals? Because conv skip is negative. So it's going to decrease I. So I want to go through this again. We're going to start off with the minimum of the size minus 1, which is the last one in conv begin. Yes, so if conv begin is this really large value, it's going to start at the last one. And then it's going to decrement, and it's going to keep on doing that and while I is greater than or equal to 0. So once I becomes negative, that's why we needed the int, not the size t. While it's positive and it's greater than conv end, because again, up to but not including, then what are we going to do? Item is this contents.at, and then we're going to push back broke something. No matching function for call to min standard vector, the size type, and an int. Okay, fine. Because it's a size t, it needs to be cast it to int. All the tests pass. Whoops. Let's go to the tests now. Let's add a few more. So we're going to say slice with a positive value. So in this case, we'll just 3, 4, 5, 6, 7, 8, 9. So if I say 1, I should get 1, 2, 3, 4, 5, 6, 7, 8, 9. Why am I doing this? Well, because now I want to do a 2, and this should be well, okay, let me go ahead and do this one. So I've got a 2, and I wanted to then start from 1. Okay. So this should be 1, 3, 5, 7, 9. And then this should be 2, 4, 6, 8, and that. All those passed. We can add, just something to it just so that we can see that it does indeed run the test. So the test is failing. Yeah, there. Okay. So this is not just a positive value. This is a positive value. No, that's fine. The positive value and non default, begin, and end. Okay, and so for this, let's do this as, 7. And yep, 246 is what it should be. All right, now we're going to do the same thing, but for negative values. In fact, how far down is that? There. And we're just going to do a quick little 809, 839, substitute positive for negative, there. And we're going to say -1, -2, -2, -2, and this is actually, well, I'll do this in a second, but for this one, it should be 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, and I know stuff is going to fail, but I want this one to pass. And so it started failing at 823, which is where I thought it would. So that's a good thing. And this one now is, there you go. Okay. So 823 says it should be 97531. Is that correct? Yes. 97531. That is correct. Now for this one, I want it to start on, it started on the last one by default, so I want it to start on the next to last one by default. So it should be 8, 6, 4, 2. Yep, and now the only one that's failing is this last one, and that is starting at, I'm going to go -1, -7, -2, and just let it run and fail. 975 is exactly what it should be. Yay! A couple other tests we can do, and that is slice with begin and end out of range should produce copy of array. How about that? And how are we going to do that? We're going to say -300 to +300 with a skip of 1. And this should be there. Okay, that passed. Again, we can, change the output just so we can see that it did in fact. Yep. And we're going to do another one because we kind of want to go the other way. So this is a slice with begin, and then out of range should produce an empty array. Why? Because we're going to say 300 to negative 300. Of course, it's going to fail because I didn't change the test, but that's all right. All right, now we're going to copy these two again and do the same thing with negative indexes. -1, a -1 should produce empty, should produce copy of the array, but reversed. Okay. And this is going to be from positive 300 to negative 300. And now this would be negative 300 to positive 300, but with a negative, should be an empty array. Those should all pass now. Oh, yeah, I should actually. So that's 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, there. Didn't notice that it already ran. That's good. Now, so slice with a skip value of 0. There's a couple things I want to do here. The output is 1. That is not right. Oh. I didn't do a skip value of 0. I did a index of 0. So it was correct. Good. It should not have put out anything. And then I think last would be should return error. And all that I'm going to do is there. Get result, and then this should be an error. I'm giving an empty error message, but that's so I can just copy it because I'm expecting it to be an error. Yeah, don't know how to slice this expression. That's fine. Oh, it needs a period. think that's good. We have all of our tests passing, and we now have slicing on arrays. And one more just to prove it works. So all that I'm going to do is I'm going to say colon colon 2 there we go, colon colon -1. So it should give us 1, 3, 5, 7, 9, and then in reverse order though. (19, 17, 15, 13, 11, 9, 7, 5, 3, 1). Yep. Probably would have been faster to just type it out. But again, just to show that, yes, it's working. Say, Corey, couldn't we have done that with a -2? Yeah, but that's not the point. You know what? Here, let's make it better. Let's make it, how about a -3? And it should start at 15, yep. Because that's 19 is -1, 17 was -2, and now 15. Okay, all of that, my hands are actually hurting because that was a lot of typing. I've been going for a little over 2 hours. Let's see what changes. Ooh. In our parser, we have a space at the end of slice. How dare we? And you know what? I do this anyway. Make clean. All right. Got our slicing. We added it to garbage collected. We added it to the array. We added the opcodes for it. Array slice. Oh, these are our tests. Okay, so let's do this in this order. Let's say git add include computed expression.hpp and source computed expression .cpp. Why? Because what does this include? This includes the dunder slice method. So add dunder slice to computed expression. All right. Why? Because now we can git add our include opcode and our source program dump and source program execute. And why are we adding these? Because this is the commit to add slice opcode. And the slice opcode required that computed expression slice exist. And now we can say, Corey, what are we doing now? I don't remember. Get status. The make file and bison and our include for the AST node slice and our source for the AST node slice. And now that's going to be the message is support for slicing syntax. There we go. And now the last one, get commit the rest of them, and that is going to be add slice support to computed expression array. All right. Rerun our documentation. We're almost done with this one. That was a lot to do. I don't even remember what all we did. We started off, oh yeah, we couldn't even print out arrays. Well, we can now. So for, I think I normally capitalize that. Episode, I don't remember. 48. Episode 48. I didn't think I'd get this far to tell you the truth. All right, and get tag. There we go. Last a little bit. Sorry, my arm's really hard. I've got to take a break. 5950. But we've got slices for arrays. Still had to add them to strings, but the heavy lifting is done. That is figuring out the default behavior when things don't exist, and now we just have to copy and paste and replace as appropriate for strings that are Unicode aware. And then we'll have a leg up on Python. Sure, yeah. Python, I guarantee, is a lot faster than this language. But anyway, yeah, it should work. I'm happy about that. And I think we will call it a day at this point. And as always, thank you for joining me. And I hope it was good for something, for someone out there to see this. Thanks. Have a great day. Bye.